Hello, I'm Cheryl. In this problem, we're going to be using Lagrange multipliers to find the maximum of my function f of xyz equals x times y times z with two constraints. X plus y plus z is 32 and x minus y plus z equals 0. So I'm going to begin by writing my constraints as functions of x, y, and z. So my first function is going to be g of xyz equals x plus y plus z minus 32. And my second function, I'll call it h of x, y, and z, is going to be x minus y plus z. Okay, so to use Lagrange multipliers, what I'll do is I'll take the gradient of f of x, y, and z and set that equal to lambda times the gradient of g of x, y, and z plus mu times the gradient of h of x, y, and z. All right, so the gradient of f. So I'll take the partial with respect to x, so that's going to be yz times my vector I, plus the partial with respect to y, that will be xz times my vector j, plus the partial with respect to z, so that will be xy times my vector k. That's going to equal lambda times my gradient of g. So the partial of g with respect to x is just going to be I. With respect to y will be 1 times vector j. With respect to z will be 1 times vector k. Then I'll add mu times the gradient of my function h. So that's going to be I minus j plus k. All right, so with a little simplifying, I will have yz times vector I plus xz times my vector j plus xy times my vector k. And that's going to be equal to lambda I plus lambda j plus lambda k plus mu I minus mu j plus mu times k. On the right-hand side, I'm going to group all the I components, j components, and k components together. So I've got yzi plus xzj plus xyk, and that's going to be equal to lambda plus mu times my vector I, because I'm combining this term and that term. Then I'll combine the j components together, so I will have lambda minus mu times my vector j, and then when I combine those last terms, I will get lambda plus mu times my vector k. All right, so what I need to do is I need to set the components equal to each other. So on the left-hand side, my I component is y plus z, and on the right-hand side, it's lambda plus mu. So they must be the same. So I'm going to write yz equals lambda plus mu. Xz must be equal to lambda minus mu. So xz is lambda minus mu. Xy has to be the same thing as lambda plus mu. So I have three equations, but remember what I need to do is I also have to have my g of x, which is x plus y plus z minus 32 equals 0. And for my function h, I have x minus y plus z equals 0. I now have 5 equations and 5 unknowns, so I need to solve this system for x, y, and z. All right, so I'm going to begin by combining those first 2 equations. And I notice that if I add these 2 together, I'm going to end up with y plus z, or yz, plus xz equals 2 lambda. And if I combine these 2 together and I add them, I'm going to end up with xz plus xy equals 2 lambda plus 0. All right, I'm now going to take each of these and solve them for lambda. So I'm going to have yz plus xz all over 2 equals lambda, and xz plus xy all over 2 equals lambda. Now, this equation equals lambda, and so does this one. So they must be equivalent to each other. So let's go ahead and write yz plus xz all over 2 equals xz plus xy all over 2. Multiplying both sides by 2, I get yz plus xz equals xz plus xy. And I notice that both terms have an xz in them. So I'll subtract xz from both sides, and I get yz equals xy. And dividing both sides by y, I end up with z being equal to x. Okay, what do I do next? Well, next, I'm going to take the fact that x and z are the same and plug them into those other 2 equations that I haven't used yet. So when I do that, I'm going to have x plus y plus x minus 32 equals 0. And in my second equation, I'll have x minus y plus x equals 0. Okay. This can be rewritten as 2x plus y equals 32, if I move that 32 over, and 2x minus y equals 0. If I take these 2 equations and add them together, I'm going to end up with 4x is equal to 32, which means that x is going to equal 8. Okay, so now if x equals 8, then I know what z is. If x equals 8, then z is also 8. And if z equals 8, the only piece that I'm missing is y, and I can plug that into one of my other equations. And for instance, I know that x minus y plus z equals 0, so that's going to tell me that 8 minus y plus 8 is going to equal 0, which means that y is going to equal 16. So I have the point 8, 16, 8 as my possible maximum. Now, if you take a look at this, this particular function won't have a minimum, so this is where the maximum will occur. So what is that maximum? Well, we just have to plug it into the original problem. So I actually want to calculate f of that number. So I'm going to have 8 times 16 times 8, which is 1,024. I hope that was helpful. Thanks.